So my name is Lena Schnabel. I'm working at the Fraunhofer Institute for Solar Energy Systems in Freiburg, and Kurt and some of the others asked me to join here this workshop, and let's see if and how helpful this could be. I was a little bit looking around before and yesterday what I could bring in here into this workshop, and hopefully it will be interesting for you. So maybe some words about me. I'm leading the Department of Heating and Cooling Technologies at the Fraunhofer Institute, and we worked a lot in adsorption technologies and also vapor compression systems. We are strongly connected to the European industry with a focus on building heat pumps. So that's our main work topic at the moment, but we also start to step into the high temperature heat pumps and also higher capacities. So there is a little, or there's a lot of change ongoing at the moment, and some examples I will have here in this presentation. Maybe just some words for the background. Germany and also Europe aim to be climate neutral until 2050, and this causes a lot of effects on emissions for the different sectors. So we have here on the right side a figure where it says that the industrial sector has to reduce its emissions by 50% until 2030, and this is just 9 years. So it's quite fast. So the period or the time we have is very limited to get more efficient and CO2 neutral systems running real in applications and in operation. This is one aspect, and the other one is that nearly 70% of the energy used in the industry is provided by fuels. So it's a big amount which has to be substituted. And the ways how Germany and also Europe tries to address this topic is to substitute and to focus on energy efficiency. And substitution is discussed by hydrogen and electricity, and additionally energy efficiency. This is just a picture on the same discussions for the European level. So also there, it's said that heat pumps will play a much bigger role than at the moment, and there has to be a big growth of this technology. This is just picturing the things I said, that also looking not only to the industry but also to the total heating and cooling demand. 50% in Europe is caused of the energy demand in Europe is caused by heating and cooling. For Germany, it's 60% because it's a little bit colder here, so we need even more in this area. And the percentage used for space heating is 27%, and process heating is 16%. And you can see here on this picture that a lot of gas is still burned there. There's a little bit of biomass, but the heat pumps, electricity-driven processes is just 1% at the moment. And if we think about this 2030, then we have just these 9 years. So we have to think about technologies which can be implemented quite fast. I have two areas for the following slides. So one area is the heat pumps for the building sector. This is a picture also for Germany. So we have at the moment for the building sector, so that's the sector where most of the heat pumps are sold, we have 12% of the total amount of heat generators sold. And a lot of studies, there are a lot of studies have been done in the last years, trying to calculate how many heat pumps do we need in order to reach the goals of the climate action plans in different ways or different scenarios. And here you can see, according or depending on the scenario which is taken, we have strongly to enlarge the numbers of heat pumps which have to be produced and installed and have to go into safe operation. So until 2030, it's not factor 10, but maybe 8 or something like that. And until 2050, it's nearly a factor 10, which has to be reached by the heat pumps used for the building sector. So also this is illustrating that the status we have at the moment, even in this sector where we know that heat pumps are already quite familiar. So in new buildings, we have roughly 50% for the heating installations are heat pumps at the moment. So there it's, yeah, it becomes familiar at the moment also for the installers. But even there, we have a big challenge to approach the needs of increasing the numbers of heat pumps. And I think for what I can see in the industry, that is there is still a lot of discussions ongoing around the refrigerants. So they are still discussing what is the right choice for the refrigerants for the future, and they need a kind of sustainable and long term lasting decision in this point. And we need, especially for Europe, I do not know about the US situation, but we need a more industrialized production of heat pumps. So we have a lot of companies in Europe selling 5,000 to 10,000 pieces per year. And this is not enough, and there has to be a much higher level of industrialization in this area. Sorry, that was a wrong direction. This is one example of a project we get started last year at the Fraunhofer Institute, where the idea is to bring the European heat pump industry together. So we said, let's have a look on this limit of these 150 grams for propane, and let's see if we can design the system in a way, or the refrigerant cycle in a way, that we can reach the amount of capacity which is used for buildings with these 150 grams. And we said it would be great to reach something in between 5 to 10 kilowatts with these 150 grams, and to offer these kind of development for not only one company, but to bring together the industry in order to really accelerate the process of industrial development. And we showed in the pre-project that these 8 kilowatts are possible. So there are aspects in efficiency and COP which have to be increased, but it seems to be possible to address this capacity level. And we started a process last year with these companies mentioned here, and we are under discussions with even more companies in order to develop this charge-reduced heat pump module with propane, and to make it for them available in a period of 2.5 years, that they can use it afterwards in their way and to bring it into the market. And the idea is really to get much more knowledge about design for these charge-reduced components which we are using there. So there are different ways to reduce the charge in these refrigerant cycles. And we created by this a great platform also for the network between the heat pump manufacturers, but also for component suppliers and the heat pump manufacturers. And I'm very happy that we had the chance to start this project last year, and I hope that that this could be a way to accelerate the process. Coming to the industrial applications, there are a lot of analysis available in order to find out where are the technical potentials of processes which can be substituted or supported by heat pumps. And they are mainly these food and tobacco, paper and chemical. And I think you wrote it already in your paper, which you sent around before this workshop. This should be the areas where we should try to address in a first step the substitution of fossil fuels in order to get there the process heating by burning fuels or burning fossil fuels substituted.
Lena,
But,
this is Joe.
sorry?
Lena, just real quick. I was just going to give you a warning, maybe a 2-minute warning. We're about 10 minutes behind. So
Yeah. Okay. I have just one slide left, I think. Okay. So I think even there it's often more about safe operation in all these industrial processes than about energy efficiency. So we have to keep the energy efficiency covered by this main aspect of safe operation, and we have maybe more to bring simple systems into the market. I will just skip this. That's a way to also use thermally driven heat pumps and using water as refrigerant. We can discuss this maybe later if there are questions, but I will just come to the last slide. My feeling at the moment is that it's really necessary to work together at the moment to bring experts and the industry and also the operators together and to find efficient and simple ways to bring systems into the market, because there is not too much time, or there is not much time until 2050 if we want to reach the climate goals. And for my experience for all these industrial processes is that we have to keep the reliability in focus. This is for the applications. It's the main point that the system is running, because otherwise they get problems on other points. And the third aspect, which is important from my perspective, is just make it sustainable. So use natural refrigerants, to use not complex materials, and get the maintainability into focus again, to make it easy to repair, to exchange parts of the systems, and and maybe one aspect it's covered here. I think there is a lot of or there are many chances covered by KI or these control and failure detection strategies, which can be used to keep the efficiency high, also if the system is running in a long period of operation. And we should use this also. So thanks a lot.